It's recording. Okay, so today we're going to begin review for quarter one test. So this is number one. What is it that we need to do with this problem first? Distribute, okay? And this is going to be a big theme in this class that we've been working on a lot, is distribution. These notes, the reason why I'm making them so detailed, all of these notes, you guys do need to take your notes for classwork grade, but all of these notes are also being posted onto Canvas along with the class video. The class video and notes from Friday are on Canvas. They were put on Canvas Friday afternoon. These are there for you guys to use, to go back, to look at, to study, to use, to review for your tests, okay? If you guys miss a class for some reason, you can always go to Canvas and watch the video of our class and watch what I'm doing up here. It's our class. Okay, so you don't ever miss a class. You always have access to our class, even if you're not here. So there's really no reason that anybody should ever fail this class. Not with the new things that I've put in place for you, okay? So go to Canvas, make sure you're using Canvas, make sure that you're using it. Yes. See me after class, okay? Everybody else in here should be on Canvas because we've spent quite a bit of time now with that. All right, so make sure you go into Canvas. All of these notes are going to be on there. That's why I'm making them nice and detailed. So distribute. Problem number 2. This type of problem is called a proportion, and we have to solve for x. So in this top problem, we're trying to solve for n if that's possible. But in this top problem, this was an expression. It wasn't an equation. There was no equal sign. So it's just an expression. So whenever you see a mathematical expression, the most you can ever do with it is simplify it. And so that's what we've done here. But when you have an equation, then we can solve for something, okay? So we're always trying to solve for the variable, but since this was an expression and not an equation, all we could do is simplify. So what's the first line of business with this type of problem? Somebody say cross multiply? So we'll just cross multiply. So let's go ahead and get rid of the 10 on this side. So 10 times 3 minus 9 over 10 is equal to 10 times x minus 2 over 12. Whatever we do to one side, you must do to the other. So if we multiply the left side by 10 to get rid of the denominator, we have to multiply the right side by 10 too. In this case, this allows us to cancel that out, and we have 3 minus 9 is equal to 10 times x minus 2 over 12. Well, this is just negative 6, so we could have written negative 6 to begin with, but that's fine. Now, we want to try to get 12 out of the denominator here. So we're going to multiply this side by 12, but we also have to multiply this side by 12. So that allows us to get 12 out here. Then we have 12 times 6, which is 72. And that's 10 times x minus 2. So now what are we doing here? It's distribute. We're back up to problem number 1, distribution. So we're going to distribute. (10x minus 20). And we're going to add 20 to both sides. And we have 92 is equal to 10x. And so we're going to divide by 10, and we have x is equal to 92 over 10. And is there a common factor? What's the greatest common factor to both of these? 2. So to simplify this, we just have to simplify. So 2 into the top is going to be 46 over 5. And that's it. And we're done. Number 3. X plus 3 is equal to 30. Minus 3, minus 3. X equals 27. So the big deal with this problem is to distribute the negative sign. And now we have to get the variables on one side, get the numbers on the other, and then solve for that variable by combining like terms. So we'll add 11 to this side, add 11 to that side, and then we're at negative 2p is minus p plus 3. Now we'll get the p on the left side, so we'll add p, and then we're at negative p is equal to 3. And then we divide by negative 1. P is equal to negative 3. Number 5. So 2 times 5n plus 6 plus 12 is equal to 7 times n minus 3. We see a lot of distribution here in this problem. That's basically all this problem is distribute. You're going to distribute and then combine like terms. Okay? So let's start distributing. So we have 10n plus 12 is equal to minus 21. Subtract 24 from both sides. We'll subtract an n, 7n from this side. N is equal to negative 15. So number 6, V the absolute value of V divided by 3 is equal to 3. We're going to drop the absolute value bars, set it to positive 3, and set it to negative 3. Cross multiply. So the answer would be v is equal to 9 and v is equal to negative 9. So you have two choices for v. Seven. The absolute value, 5 minus x is equal to 1. We are going to drop the absolute value bars and set 5 minus x equal to positive 1, and 5 minus x is equal to negative 1. Solve for x. So subtract 5 from both sides. The absolute value of minus k plus 6 plus 4 is equal to 19. We're going to isolate the absolute value bars on one side. The first thing we're going to do is subtract 4 from both sides. And we're right back up here with this type of problem, number 7. And you can see that this here is set up identically to this. Okay, so we're going to do the same thing we did for number 7. Drop the absolute value bars and set negative k plus 6 equal to positive 15. And minus k plus 6 equal to negative 15. So subtract 6 from this side, subtract 6 from this side. Minus k is equal to 9. Divide by minus 1. k is equal to -9. So for this one, so for number 9, this is going to be an inequality. Yes, Mr. Tillis. Yep. So 8 minus 2n is less than -6 times plus 1. So we see that we have to distribute the -6, and so that's going to be our first line of business. And now we're just combining like terms. And so I'm going to subtract 8 from this side and this side. Subtract 12n from this side. So here we have n is greater than 1. So whenever we divide by a negative number, I divided by -14, you must flip the sign. So it becomes, instead of less than, it becomes greater than. Yes? What's that? Yeah, on this side the n's fall out. Yeah, so 12n minus 12n becomes 0 on this side. But I have to subtract the 12n from the left side too. So if I subtract it from one side, I have to do it to the other side. Whatever I do to one side, I must also do it to the other side, always. Okay, so on this side, yes, the n's cancel out there, and up here, the 8's cancel out. Now we have to put this on a number line. So what does this look like on a number line? N is greater than 1. Well, if we just arbitrarily, we just put 1 right here, then is this going to be an open or a closed circle? It's open. To the right or left? To the right. Okay. And so that's it. And we're finished. So number 10 is going to be minus So this is a compound inequality because it's an OR case. Remember we did the and the OR? So this is a compound inequality. So on this one we can just directly divide by -5, divide by -5, and then we have P is less than or equal to 4. That was really straightforward. This one over here is also, it's pretty good. So we're just going to add 5 to both sides. Add 5. Add 5. The 5s effectively, they're going to cancel out, and we'll be left with P is less than -2. So -2, is that going to be open or closed? And P is less than or equal to 4? Yes. Thank you. Here, I'm going to do number 10 again, okay? I forgot to flip the sign. Good catch. When divide by a negative number, flip the sign, okay? So I divided by -5 but didn't flip the sign. Okay? So that was an error that needs to flip. Do you guys want me to redo it or just make the change? Okay, all right. Some people want to see the whole thing redone again, but that's good if you guys just want to see the change. Okay, so in this case, this needs to flip. So the new results, though, okay, so this is the new result. The new result is going to be P is greater than or equal to 4, and P is less than -2. So what we have here is -2, I'll just draw them below it. And so that's going to be P is less than -2. And so greater than or equal to 4. And so that's going to be P is greater than or equal to 4. So that would be the result. Yes. Number 11. So this is a compound inequality of the AND type. And we're going to directly divide by 5. So that P is greater than 6. And over here, we're going to cross multiply. So let's draw our number line. We have P is greater than 6. Open or closed circle. And we have P is less than 5. Open or closed. And so that's what that would look like. X So this is another compound inequality of the and type, and we'll just divide right by 4. X is greater than 7, and we're going to cross multiply, so 4 times and that's going to leave us with X is less than 56, and 56 is 112. So if we were to graph this on a number line, and we'll shrink this down. So we're looking for X is greater than 7, so we'll just put 7 here. Open or closed? Open. And we'll go ahead and just put 112 up here. Say that that's 112. Of course, that's not to scale. Everybody sees that. But 112 up here, X is less than 112. So we have an open circle here, and we have an arrow going the other way. But here, we're looking for, we want X to be greater than 7 and less than 112. So what area do we need to focus in on? The intersection. The intersection. So we need the intersection. We need the intersection. The intersection is going to be what? The intersection is just going to be that area that occurs between the two of them. And so this would be the final solution. Unless you're comfortable with doing this right from start, always do them separately first. Always just put them separately on the graph first, and then determine where that intersection is, and then just rewrite your graph with that intersection, just like I've done here. That's the sure way of doing it, so that you would never have any questions. Just put them both on, and then just put the intersection. Number 13. Okay. If we look back to number 7, let's look at what we did on number 7. On number 7, we had an absolute value, 5 minus x is equal to 1. And all we did was drop the absolute value bars and then set that to positive and minus 1. On this one, we have basically the same structure, but instead of an equal sign, we have a greater sign, or an inequality sign. So for this type, we're going to set this, we're going to drop the bars, greater than 37, and flip the sign and put a negative. So, and now we can just solve the inequalities. So now we have minus 4v. We're going to subtract 5 from both sides, and that's going to leave us with is greater than 42. It's 4v is greater than 42. So divide by negative 4. And we have to flip the sign, right? So v is less than negative 42 over 4. Now we have to simplify using the, yes? Oh, yeah. 37 minus 5 is 32, not 42. Simplify using the greatest common factor. In this case, it's going to be what? 4. So we just, well, 4 goes into 32 8 times, we know that. So v is less than negative 8. Now for this one up here, let's just rewrite that down here. Yes. Actually, no, because I've got somebody out. Wait till he comes back. Okay, so in this one we're going to do the same thing. We'll just subtract 5, and we have minus 4v is less than minus 42. Divide by negative 4, and v is now greater than again, use the GCF, so 2 is the GCF here. So 2 goes into 42 21 times. 21 over 2. Make sure you flip the sign. Same thing here. I'll flip the sign there too. Okay, so we're going to graph this. We have v is less than negative 8, so let's go ahead and put negative 8. And we have that v is greater than 21 halves, or 10.5. So roughly 10.5. Well, it is 10.5. So b is greater than 21/2. And that would be the result. Okay, so a couple things. Let's just review this one more time. So we have an absolute value inequality. We solve it very similar to just an absolute value equation, but we're going to drop the absolute value bars and set it greater than or equal to greater than 37. But this time, when we set it equal to negative 37, we have to flip the sign. Okay, so make sure you flip this sign. So flip the sign when you set it less than negative 37. So flip that sign. With the equal sign, of course, because it's an equal sign, we can just leave the equal sign, right? We don't have to worry about flipping a sign. It's an equal sign. And so it just stays equal if we try to flip it anyway. But over here, when you get the absolute value inequality, always make sure you always set it to positive and negative, the same thing, but flip that sign when you set it equal to the negative number. And then, of course, you've got to worry about flipping signs as you solve through it. Okay, so we are going to we're going to stop there today, and I need to take attendance. So what I'm going to do